Now, equilibrium is reached in a closed container whenever the rate of the forward reaction and the rate of the reverse reaction are equal. How would that come about? If we now think about those two little men that we watched, then initially the guy on the left had a lot of reactants in his container. The concentration was very high, so he could work very fast. If we talk science, we can say the concentration was high, and therefore the rate of the reaction, of the forward reaction, is very high. But as the reaction continues, he uses up the substance. So in other words, the concentration is decreasing. And as the concentration is decreasing, the rate of the forward reaction is decreasing. So you've got it, the forward reaction starts at a high rate, and then as the concentration decreases, the rate of the forward reaction decreases. The guy that's working in that direction is going slower and slower all the time. Now, about the guy on the right, he starts with nothing. So he cannot build anything. So the rate of the reverse reaction is actually zero right at the beginning. But as something falls into that crate, then he can pass it back. And then, as it becomes more and more in his crate, his rate increases. And the moment his rate now increases and this guy's rate decreases, so the moment those two are equal, then you will find that the moment that one throws, that one falls back. So in other words, the rate of the forward and the reverse reactions are equal, and we find that it is in equilibrium. If we look at this quickly, there we've got the two guys, and the guy on the left has again got his, and you can see he's working very fast because he's got a high concentration there, and the guy on the right is doing absolutely nothing. But now he starts, but very slowly, and the guy on the left already starts working a little bit slower because his concentration is decreasing. But check the guy on the right. As his concentration increases, he is working faster and faster and faster, and eventually you will find that they will reach the point where the rate of the forward reaction is equal to the rate of the reverse reaction, where they are working at exactly the same speed. And that is now the point. There they've reached equilibrium. And what you will notice now, when equilibrium is reached, is that the amount in the beaker on the left remains the same, and the amount on the right remains the same, because the moment he takes a molecule, he receives a molecule. So they don't change at all.